Hi, I'm Donald.
I'm Helen.
And this is my wife, Helen. And so Helen is a glass artist, and I work in computers. And Helen came to me a couple of days ago and was asking, how can I, for a specific piece of glass, look at what color it is under light? Which was a strange question to me. But with a background in science, I know in physics, I know a lot about light colors, and so in the electromagnetic spectrum. I actually sound intelligent there. And so I asked her a bunch of questions in response, and so we kind of went back and forth trying to figure out for a piece of glass. So what's special about this glass?
Well, I'm going to go ahead and take it out of the thing here. So this particular glass right here, color shifts depending on what the kind of light is that's shining on it. So it shifts from what you see right now is kind of a reddish color, but it's also green. So it shifts from a reddish color to a green color. In fluorescent light, it's completely green, and in under natural lighting and some of the other lighting, it turns more red.
So the question kind of came out is what causes that? What's the property of the light bulb or the light itself?
Right. So when I display it, I can take advantage of that color shift.
Mm-hmm.
So I was trying to figure out what lighting to use. I mean, what fake lighting, basically, to use to influence the color of the glass itself.
And so what I did was, after coming around to that question, I set up a little Arduino sketch and a device here that I built. And you can switch to this other camera, and you can see it. And a little keypad and RGB display and a multicolor LED, so that as I change the value of red, green, or blue that's being displayed through the LED, it'll actually change the amount that's coming through this one RGB LED onto the piece of glass, so you can tell what exactly the properties are. And it actually came out to be pretty interesting. So from the keypad here, I can reset the values to 80%, which is for our red and green and blue, which makes it just basically a white light. Reset everything, or make it all very bright, or change how much I actually change the increment, or switch it from actual 0 to 255 RGB values to percentages of how much percent of light. Now this isn't measuring intensity, it's only by the amount of power going to a specific red, green, or blue LED. But it actually came out to work pretty well.
So do we need to turn off all the lights now?
Yep, so what we can see, as we're going to go ahead and switch off some lights to be able to have the light just on the LED, we start with standard RGB, that's white light, that is 80% of red and green and blue, and the piece of glass looks this reddish color. And so what I found is that I slowly decrease the red. It actually becomes just a little bit less red, but it's still effectively red until I get down to about 15 to 20% red, and anything more than that, at that point, with that amount of red color, with same amounts of 80% green and blue, it still looks kind of green. But once I get down to very low amounts of red, it turns completely green. So I was like, oh, well, what if I left red the same at 80% and then just brought down the green to do the same thing? Well, it turns out that it actually just gets more red. And so this was kind of interesting to me because, well, what does that really mean? That means that red is more important than green light. Well, if I try the same thing with blue, what happens? And then as I lower the blue here, it actually just looks kind of more yellow, but it's still mostly red, even in fact. So blue almost has no effect on the color. And what we can really see is that if I lower all of so I'm zeroing out the red and green, and here's this blue, and it's reset it to 80%, you'll see this thing just kind of gets darker and darker. What that really means is that it's not really, oh, there's another light over there. That's why that brief flicker of red came in. The blue light, and it's actually Still looks bright blue coming through the... And of course our other camera just shut off. Thank you.
Yeah.
Oh, no, I've still got my cell phone
Okay.
going. Here. Alright, as we're switching cameras here. Your thumb's in the way.
No, with my thumb.
Oh,
Hey,
finger.
Is it recording?
Yeah, it's still recording.
Oh, okay.
Yeah, I started it when we started everything. So,
Oh, okay.
so anyway, the blue, while it has an effect, it actually mostly appears just plain dark. And what that means is most of the blue light is actually being absorbed by the piece of glass. So what that, in terms of, and so let me go back down to, if I set the blue to 0 and the red, slowly increase it, see how it almost instantly pops red? That means that the light is actually scattering the red light, or the glass is scattering the red light most of all, and green just makes it start appearing green. But you notice how the green on the white paper is brighter than the green in the glass. That means it's absorbing some of that green as well. So in effect, what's happening is as you go from, the electromagnetic spectrum is that range of red to blue, the infrareds to the ultraviolets. That means that those lower energy reds are scattered more. And so infrared light would be scattered more by this and broadcast more. But then the ultraviolets, those high blues, are actually absorbed more. With that, in terms of Helen's work with the glass, she sometimes uses these ultraviolet epoxies. Those ultraviolet epoxies depend on ultraviolet light hitting the epoxy to be able to cure it. Well, if you have a piece of glass like this, and you have that epoxy, if it's behind the glass and you're shining the light through the front of it, it will be absorbed and it will take much longer to actually adhere or cure. So if you're doing that kind of thing, you need to do it from the backside or through a clear material. Is that pretty accurate, huh?
Yes. Pardon me.
Yeah, and so for that's all I got. So.
Anyway, so we're going to do some more experimentation with this whole setup to help with displaying my glass, because we want to incorporate his, the Arduino stuff, his work, and my work to make something that's more than what they are by themselves. Create some really cool artistic technology. Because I can speak.
Yep. Well, it's just the idea that we can use the technology to see, in terms of the art itself, what would be the best way to present something, or the best light. And, okay, and well, we just wanted to let people know what we found out, because from the science perspective, I thought this was pretty interesting to see something like this, a glass material that scatters light differently depending on its wavelength. And what do you think from the artistic perspective?
I think it's pretty cool. There's a lot of options, because especially looking at the ultraviolet range, I know some of the lights do fluoresce. Glass do fluoresce all by themselves with an ultraviolet light. So it's kind of cool to start experimenting with that kind of stuff too, just to see how the light, because it's all about color, which is light, bouncing and reflecting and transmitting and whatever, and just trying to figure out how I can manipulate the art even more with light.
Very cool.
So, yeah.
We just thought everybody would want to know.
All right. I guess that's it.
That's it.
All right.
Cut. Bye.